Greetings. Welcome to Learning Happy Hour. I'm Mitch Densley.
My name is Jason Yates.
In this episode, we're going to tackle 4 features that are in PanOS 9.0. And this is a subset episode of a longer recording we did, which really just included too much information. So we're going to break all of that information out over our 9.0 series, beginning with this episode.
That's right. We've got several 9.0 episodes to pay attention to. So this one, we're covering wildcard masks, and we're covering Master Key. What else?
We're going to talk about FQDN Address Object support, the TTLs specifically, and dynamic DNS has been added to the PanOS 9.0 firewalls.
And we got some great advice from Richard Kim, who is an eTAC manager, on upgrading to 9.0, so you don't want to miss that. Plus, in later episodes, we cover more features, and we have a full-length interview with Richard Kim. So if you're excited about 9.0, you don't want to miss this series.
Jason teaches us about our pinky fingers.
And Mitch mispronounces corpse.
Stay tuned.
Cheers.
Cheers.
It's that time again. It's Learning Happy Hour with Mitch and Jason. BYOB and bring your own brain. Cheers.
So, Jason, I got to tell you, I'm really excited about this episode and PanOS 9.0. I've had some students ask me in the past for features that we're going to talk about today, specifically customers and students who have a lot of retail organizations that they have to manage, or even just a bunch of remote locations like branch offices for banks and whatnot. And what's interesting about their use case or scenario is all of these remote locations have a lot in common, and all they want to do is cookie cutter repeat configurations from Panorama down and rules in every firewall to accommodate what's unique about all those stores, even though minus an address being unique or one little variable being unique, everything else about them is the same.
Before we dig into that, I just want to mention to you, Mitch, that I know you live in Colorado. Do you have any snow where you're at?
I do, in fact. Switch background. And it's snowing right now, as you can see. And then we'll switch back to the bar. There we go.
Oh, wow. You have magic powers.
I indeed do.
Is that part of the 9.0 upgrade?
No, sadly, that was not something added. But it's a feature request we could definitely ask for.
See, I live in the Pacific Northwest, and so depending on where you are up here, it doesn't snow all that often. So it snowed the other day.
You guys got snow?
It did. It snowed.
That's
and
awesome.
I'm not sure if this will work. Maybe.
I see
maybe
it. No.
not.
Yeah. Holy cow. So is that your backyard or?
Yeah. I took a picture of my backyard and of my orchard, and so I'm dressed up. We're all kind of huddled up, and kids stayed home a little bit. In fact, I've got hot cocoa, and I got a little mocha going on with a little peppermint, just because it's cold outside.
So the next thing we want to talk about is wildcard address objects, and specifically for use in the security policy. Now, a wildcard address object, those of you with a Cisco background may recognize this as a technique or a term or a capability, but it's just now being introduced into PanOS. So those of you who are unfamiliar with a wildcard mask, I want to do a quick overview of how wildcard masks work. Now, when you do create an address object, you define, your IP address, and then you've got an associated mask. And that typically tells you what portion of an address is network and what portion of an address is host. But in a wildcard mask, the meanings of each bit in the mask are flipped. So now a binary 0, instead of representing a wildcard as it does in a subnet mask, it represents an exact match bit. And then a binary 1 in a wildcard mask is representing an any or a wildcard. So as you're trying to define this, you need to compare the IP address exactly bit for bit with your wildcard mask. And once you've defined that, convert it back to decimal notation, and then put it into your Palo Alto Networks firewall.
So let me stop you here for a minute.
Yeah.
So why is this important? Well, why use wildcard address objects?
That is a great question. So the main benefit of a wildcard mask is it lets me match an IP address almost 100%, but certain fields or certain octets in that address can be any values. For example, let's say that I own a company with lots of retail stores out there across the country or the globe, and each store is a cookie cutter of the next. The only thing that's unique about each store's network is the parts that have to be unique, like IP address. So let's say that every store has a schema of 192.168.x dot something, and the X represents the store number. So that gives me 256 possible stores that I could accommodate within a single octet. And then .1, the last value in the last bit position, represents, let's say, the router at the store. .2 represents the domain controller at the store, if you have them there. .3 represents the file server. .4 represents the POS controller, point of sale system, sorry. And then it just goes up from there. So every store is a clone of each other. The only thing that they're unique on is their third octet. So I'm going to do a quick quiz, Jason. I'm going to put you in the hot seat. Here is an IP address next to a wildcard mask. Now, which octet do you think is going to be the wildcard octet?
So that's the one that can vary, and
Yep.
I would say that would be the third octet where the IP address is a 0.
Exactly right. Those of you who are familiar with decimal to binary conversion, you remember that 255 is the highest possible decimal notation number for a binary value of 8 ones. So great job. Jason nailed it. The third octet is the wildcard octet. Now, let's do it again. In this case, which one's the wildcard octet?
Ooh, this would be that 168 would be the second one.
Exactly. The second octet is our wildcard octet. Very good, my friend. All right, the next one, let's see, which one's the wildcard octet?
Well, this would be the last one, but this isn't all ones in the wildcard mask.
Exactly. So can you tell what would happen with a wildcard mask like this?
Well, that would mean the first 7 bits could vary, or...
You're onto it, my friend. Very good. I'll be honest, it takes me a little bit of lead up to be able to do this in my head. So to help out, I've broken these both octets from the IP address and the wildcard mask down into binary, and let's see what they look like. So in the address, you've got all zeros in the last octet, but the wildcard mask has got all ones except the 8th bit in that octet is a 0. Now, a 0 is an exact match. So in the address, it always has to have a 0 in the first bit position in order for it to match this entry that I've created. But every other bit position can be anything. So what this translates to is this object would match only the even-numbered IP addresses within a subnet. Now, this is a fun example that kind of flexes your subnetting skill sets a little bit, at least your binary to decimal conversion capabilities. But I've done this, actually. I've created these objects, 2 of them, one that references the even numbers and one that references the odd numbers, and I've matched them in security rules. And here you can see in my traffic log, everything with an even-numbered IP address shows up according to that security rule appropriately, and then everything with an odd number IP address shows up with its corresponding security rule also. So it's super easy to do. Reference it in your security policies, and those of you with a lot of cookie cutter locations, go ahead and benefit.
That's great.
Now, something along the same lines that I want to talk about is FQDN address objects. So what you can do with an FQDN, again, fully qualified domain name, we make a query against a DNS server to resolve that back to an IP address. And when you create objects for that, they're going to represent, let's say I have an object at each location called POS controller, and that each location that translates back to 192.168.x for the wildcard address, add .3, as I think I said earlier. Now you can summarize all that up into an FQDN address object, making your configuration of your policy rules much, much easier. Something that's changed, however, in PanOS 9.0 is we're now respecting the time to live value that comes with a DNS response. So when I make a DNS query, I get a resolution back, and it has a time to live value. Up until this point, PanOS has ignored the TTL value, and it'll only re-resolve an FQDN after a configured timeout. Now that timeout, you just had to kind of know was every 30 minutes, or you could go down into the CLI and there's a command you could issue, as you see in the third bullet there, and it would reduce the FQDN refresh timeout down to a small of an interval as 10 minutes. But that was the smallest you could go to back in the day. Now with PanOS 9.0, we've elevated that capability up into the web UI, so you can see under Device, Setup, Services, hit the little gear, and you can define your own FQDN refresh time and then a stale entry timeout, after which point we will not reference that resolved address, and then we have to go through and do a re-resolution. If you give it a 0 value, however, then the timeout is ignored, and we will only reflect the TTL value for re-resolution. So I think the FQDN refresh features are great, and they contribute very, very nicely towards that multi-location management scenario I described earlier. Now,
Great.
I'm not done, though. In
Okay.
addition to that, there's one more feature which makes multi-location management that much easier, and that is dynamic DNS support. Historically, we've kind of turned our nose up to dynamic DNS and said that's a home user kind of thing, has no place in enterprise or business, but we were wrong in that statement. Because if I have VPNs, for example, and I need to be able to build a tunnel or initiate a tunnel from either the HQ location or the remote location and back again, then we need to be able to reference our peers with addresses that are valid. Now, if you have a remote location where your ISP is not giving you a static address, or you don't want to pay for a static address, you can use a dynamically changing address, and then every time your address changes, you can tell a service, a dynamic DNS service, hey, this domain name now resolves to this brand new IP address. And so we have that capability integrated into a Palo Alto Networks firewall. It's an interface-specific setting. You go to an interface, jump to the Advanced tab under Dynamic DNS, and we have native support for the different vendors that you see here listed on the screen.
So this means that the firewall is going to register its interface IP address to whatever dynamic DNS service that you're pointing it to. Is that right?
Exactly right.
All right.
So then I can build my configurations at HQ for VPN or for other types of things that need to be able to access this location. I build those configurations around the host name or whatever the address is, the domain name is. In my example here, I've got firewall.ddns.net. I did actually just register that under no IP. So that's mine now. Don't know if I'll use it or not. But the point is, now that is registering, whatever address is given, in this case to Ethernet 1, he notifies no IP. And then when I try to browse to whatever firewall.ddns.net, it resolves back to that address that's assigned to that interface and would ideally take me to that firewall.
Now this could be useful for some organizations and partners who are service providers to smaller offices who are using dynamic DNS. So
Absolutely, yeah. Managed services service provider, where there's a bunch of firewalls they're supposed to administer. Let's say I have a Panorama instance that's managing firewalls for my customers. Panorama needs to be able to talk to those firewalls to push configurations down and whatnot. And if it doesn't know the address because it changed, you're cut off. And then you got this constant phone call back to the local guy. It's messy. This is elegant.
Yeah,
now,
this is
when
great.
you go to configure this, there is a gotcha that I discovered myself. You have to create a certificate profile that contains the certificate authority that signed the certificate for the site or the service that you're registering your DNS values for. And in my case, I was using no IP. And to create the certificate profile, I did what I've done in the past, which is browse to their main website and then grab the certificate and the CA that signed their website certificate. And then I committed it, and then I go look in the system log, and it shows a DDNS entry, that's the new subtype, failed. And I was like, what? What's wrong? What did I do wrong? You know, and I started to question myself. And I did do something wrong. It was in my assumption. My assumption was that no IP or the DDNS vendor is going to use the same certificate or at least the same CA to sign the cert that the firewall is talking, or the cert for the site the firewall is talking to. Only once I grabbed here the API host value plus the base URI value, and I put them into my browser and went to that different site because they had a load balancer redirecting traffic to different servers, then I realized it was a different certificate. So their website certificate is signed by DigiCert. but their DDNS, the address that your clients phone into, has a certificate signed by GeoTrust. So keep in mind that you need to know exactly where your firewall is going to connect to, grab the appropriate certificate, populate that into a certificate profile, and everything will work as you expect.
So that registration must be via SSL, is that?
Yeah, so it depends on the vendor as to which protocols they support. For example, no IP, you can register over HTTP or HTTPS, but our firewall will only make a call out using HTTPS. That's why it's not even a configurable thing. Just because we're a firewall, we try to be secure, stuff like that.
Yeah, right, absolutely.
So, Richard, we're so glad that you're here. And so tell us again what you do for Palo Alto Networks, what your role is.
Well, I manage the eTAC team in North America. The eTAC team, yeah.
Electronic Technical Assistance Support?
Yeah, it's funny you say that because we like to change the E to whatever we think it fits best.
Yeah.
Technically, it's called the engineering tech.
Oh, okay.
But we sometimes change that E to be escalation or education or enablement.
So you do a lot of training on the support calls?
Yes, we do. Yes,
wow.
we do. In fact, we do all of the support training when we have new software releases, such as 9.0.
Nice.
So that's one of the main reasons Mitch and I wanted to talk to you. And I know 9.0 is coming out, and we're very excited. So what should customers know before they upgrade to 9.0?
Well, first of all, I think the first thing they should look at is, will my platform support 9.0?
I mean the physical firewall box.
Yes,
Okay.
yeah. Some platforms, for example, some of our legacy older devices cannot support 9.0. And so the other thing to keep in mind when you're upgrading to 9.0 is you want to review whether or not you really need that feature at this point in time. So one of the challenges I think we hit all the time, there's always going to be that balancing act of trying to get the most security you can get. And obviously with the new features, we add a lot more security capabilities.
Yeah.
And then there's always that balancing act of also making sure my network is stable. And that sort of balancing act is something that every customer has to weigh.
Right. So they need to be sure they know what they're getting when they go to 9.0.
That's right.
Now, it shouldn't be a blind upgrade.
Absolutely.
They should inform themselves about what features are going to be included in 9 and whether or not they actually need those features at that time.
Exactly. And I also like to always encourage our customers, if they have the ability, for example, to run in their labs ahead of time, run it through realistic scenarios, because everybody's environments are going to be different.
Easier way into it.
Right, exactly.
All right, Jason, the next thing we want to talk about is master key management. Now, I suspect most people have no idea what a master key is, but
if you go watch our full interview with Richard Kim, we go into more detail about our master keys and what happens when they expire, also how to renew them.
What we're going to talk about here are some improvements on that process so you don't get locked out of your firewalls unintentionally. The way we do this is we give you the option to extend your master keys for another periodic interval if you don't have time to catch up and change that master key at the defined time frame. Also, master keys have to be consistent between HA pairs, Panorama, and every firewall managed by Panorama, because that master key is used to encrypt things like passwords and private SSL keys and stuff like that. So let's talk about how Panorama can now push those master keys down also. First thing we want to show you, though, is how you can set your master key. This is going to be under Device tab, down under Master Key at the bottom, and you can change it from the default master key to your own custom. Give yourself a lifetime and a reminder time. As you see here, I've given myself 65 days to remember to change that key. Now, after you've set your master key, you can then come back in and then also define an auto-renew interval.
Now, I love this feature because it's an important part of hardening the firewall itself and securing it. Because as we talked about, you mentioned this with Richard, the default master key has been leaked, and so a security best practice is going to be updating this, but then there's a bunch of management around it. And previous before 9.0, if you didn't keep it up to date, then you risk the firewall having to be factory reset when it expires. This puts some real safety around that expiration part of it because a year is a long time to remember something. Even with the reminders, just ask my wife. I forget and lose my keys all the time. I forget to take the dog out with catastrophic results, even with reminders. So having a built-in reminder system and an auto-renew, that's really useful. And I wish I had this for my dog. Like it could automatically take the dog out or something.
Like a bathroom reset on the dog's interval. I think that's a good idea.
That would be great if it could.
Right? Somebody invent that, and then I'll pay you lots of money for it. That's great.
Maybe with robot dogs.
There we go. Well, anyway. So one of the important things, though, the fact that you have to change this master key on every single firewall. You could do it programmatically via the XML API. However, that's a lot more work than most of our customers are willing to sign up for. So
you mean it gets better?
It does. As you see in the second bullet, we can push this master key change from Panorama, and you can even create the auto-renew value as a template setting. As you can see here, I'm in my Panorama view. See the template at the top? And I could push that auto-renew interval down to all firewalls that assign to this template. But if you want to push a consistent master key to all firewalls in your organization, do so from Panorama. Under the Panorama tab, under Manage Device Summary, come down here to the bottom right and click Deploy Master Key. Now, I only have one firewall online right now, so I'll push it to him. But you would choose every firewall you have online. If you are coming off of the default master key, leave current master key empty. But if you've changed it once prior, you must supply the previous master key before you input your new master key. Click OK, and then you can see the progress window, not the LastPass window, but the progress window of that deployment down. And it'll show you the job ID on a per firewall basis, so you could go check that firewall specifically to make sure that it succeeded. Now is the time where we get to talk about something we learned. Jason, do you want to go first?
Yeah, I'll go first. Now, this is going to be a little interesting because this segment, Mitch and I like to just kind of keep it open and talk about anything that we've learned. And usually we talk about cybersecurity, or I like to talk about learning. But one of the things that I learned this week is I learned about the pinky finger. So let me share this with you. I think this is really interesting about the pinky finger. According to Wikipedia, right, but this is not where I first learned this.
Okay.
But it means little finger in Dutch. That's why they use the word pink, I guess, according to this. But what really brought my interest to it, and the reason I'm sharing this, is because a study was done. It's an older study. It's a couple of years old, but they demonstrated that without the pinky, your overall hand strength is 50% less. And
What?
in some participants, it was like 67% less. So, when we talk about the pinky, it seems like an insignificant finger.
It's
and maybe
benign.
when you do the little drinking,
Yeah, it's not even needed at all.
Right. So it turns out that it has, it's a contributing finger with its in terms of adding to the structure of the hand and its muscles. And the reason I want to share that is because there are aspects of the firewall that some of our customers may look at and think that it's kind of like the pinky finger. But in reality, it is a significant contributor to the strength of their threat prevention. And there are two that come to my mind that are like pinky finger things that people should really pay attention to. And one is decryption. Now, I know my BPA, my home firewall, I don't have decryption. I did, but I need to go back and configure that. But decryption's important. And Mitch, you gave me a hard time for not having that. And
Rightly
I deserved
so.
it. I deserved it because my firewall doesn't have a pinky finger, essentially, because it needs to be decrypting traffic, because that's a big part of where, a lot of traffic is encrypted. And the other pinky finger feature would be like URL filtering. I think it's another one that some of our customers would set aside as not being critical or central to their threat prevention, but in reality it's a big and very important part of threat prevention. So what I learned this week is you want to be sure you pay attention to every finger of your hand, including your pinky finger. Don't overlook decryption and URL filtering.
Use all your fingers.
Use all your fingers.
That's great. I was going to add on like the DNS proxy. I think of it as a pinky finger because it contributes to some of the vulnerability signatures and anti-spyware signature detection capabilities. And a lot of people kind of overlook it like a pinky finger.
I
now,
do.
I'm going to disagree with you because I think decryption is like the palm. It's
okay.
Over 80% of internet traffic nowadays is going encrypted. So I think the significance is very high. But I appreciate your perspective. Thank you for sharing that with us. So I wanted to share something interesting. This comes from Recorded Future. As you guys will see in an upcoming episode, we're going to do an interview with one of our threat researchers, Brian Lee, a fantastic threat researcher within Unit 42, which is our threat research or threat intelligence team. And he highlights some of the reasons why teams don't like to do attribution. And attribution, for those who are unfamiliar, is laying blame with whoever caused X or Y. Well, Recorded Future, a good partner of Palo Alto Networks, has gone on record assigning attribution to the Collection 1 data breach. Now, if you dig into Collection 1, you'll find out that it wasn't a breach in and of itself. It's a collection of breached data. Since the Troy Hunt put out awareness of Collection 1, we've realized there's up to 7 different collections, lots of data out there. And Recorded Future has attributed the original dumper of Collection 1 and several of the other collection data to this threat actor, Corp Z. The O is a 0. And he's a Russian hacker, allegedly, who's been seen posting a lot of this information that is shown in Collection 1 through hacker forums and Pastebin and stuff like that. Now, it was taken down very quickly. Troy Hunt got super lucky, spotted it minutes before the actual poster took it down. But what you see in the screen here is all of the different collections that Recorded Future is referencing, as well as the URL. It's a great read. Go check it out. And Troy Hunt runs a really awesome website, haveibeenpwned.com, where you can go check your email addresses and your passwords to see if they've been involved in a breach and need to be reset. So really great tools out there for you guys. Something I learned recently, Recorded Future, Corp Z.
That's great. Thank you, Troy.
Hey guys, thank you so much for your attention in this episode. There are some really awesome big picture features that we intentionally left out of this episode, which you can go see in the new features guide for PAN-OS 9.0. The URL is on your screen. And the reason we left them out was we want to do deep dives into most of them in upcoming episodes. So stay tuned for some really interesting information that is specific to PAN-OS 9.0.
So if you liked what you're seeing here, definitely check out the new features guide and follow Richard Kim's advice. Put 9.0 in your lab and start running it through its paces.
Thank you so much for watching, and a special thanks to Richard Kim for joining us in this episode. And until next time, use your pinky fingers.
And learn responsibly. Cheers!
Cheers!